Number 40, a projectile is launched from the ground with an initial velocity v0 at an angle theta above the horizontal. What's the maximum horizontal range of the projectile? Again, these projectile motion equations are all worked out on a separate YouTube video called Projectile Motion Equation Derivation. You might want to take a look at that, but we'll go through it here again. So we're going to, once again, use the second kinematic equation, but in the x direction, because we're horizontal here, right? And instead of x, we're going to call it the range. Range equals x naught plus v naught xt plus 1/2 the acceleration, the x direction, t squared. Well, we know the range if we're starting from a position of 0, and there is no acceleration in the x direction, our range is just going to equal v naught xt. All right? Our velocity in the x direction equals v naught cosine theta times t. Now, our time, we've already worked out what our time would be, total time. And that we did in multiple choice number 37. And total air time, we've got total air time equal to 2 v naught sine theta over g. So we can plug that in for our time. So R equals v naught cosine theta times our time, which is 2 v naught sine theta over g. All right. Continuing on, we have R equals v naught times v naught, we would have v naught squared times 2 sine theta cosine theta all over g. Right. All right, looking at this, we can see this term here, right? And that, going from our trig identities, we know that 2 sine theta cosine theta equals sine 2 theta. So we can plug that in for this up here. And we're left with R equals v naught squared sine 2 theta all over g. And that would correspond to D.